With my voice the way it is, I need to use the mic. Um, Hi, my name's Hugh Daniel, for those of you who haven't had the fun of running across me. Um, I guess I called this meeting to solve some problems I have and to try and see about fixing some major problems that I see in Linux space. This is a very Linux-centric meeting. Um, let me start off by explaining my work. I manage the Linux Free Swan project. Our goal is to provide a stable, solid, usable implementation of all the technologies necessary to do secure IP communications for Linux. So this is going to be a very technical talk. And I'm not trying to drive you away or anything, but this is intended to be technical. And my goal was to get as many of the European developers of crypto pieces for Unix in one place as possible. Because right now, crypto is kind of an ad hoc thing. And until crypto becomes infused at every layer of Linux or any Unix, security will be an ad hoc thing. And that means that most people won't have security. They'll have a box, they'll be running SSH, or they'll be running PGP, and they'll think they're secure. But until we put this into the system so that every copy of Linux that anyone ever extracts off of a CD or off of the net has crypto in it, top to bottom at every layer, we're not going to have security. Every box is going to have some hole in it that someone like me, who's bright enough or at least bored enough, can crawl through in there and start causing mischief or pain for someone. So this needs to be solved. And my idea here was, hey, I'm going to be in Europe. I'm going to be where a lot of the hackers are already. Let's try to get everyone involved. Okay, party time. um, could I ask someone, is that disturbing you or just me? Just me. Okay, I'll ignore it. Um, the idea here was to get people to sit down and talk about what pieces are missing and how we can start getting crypto into the various distributions, or at least the ones that come from free countries, which certainly is not the United States of America. Um, now, soon. I think down and back was the problem here. So as such, I don't expect this to be the Hugh holds forth for 2 hours sort of panel. Really what I'm trying to do is get people talking about what they've got that they can help pour into the pot. Think of this as stone soup, except that I'm not starting with a pure pot and asking and stones and asking you to bring the rest. I actually have a few of the ingredients. Specifically, our team that we put together has a working free swan or has a working IPsec implementation. It also has a working Ike daemon, both of which are lacking pieces. We have 3 paid staff that are working on pushing this forward at the moment. They need help in various areas. Most specifically, one of the first things that got me going is we need GPL'd crypto libraries. One crypto library that can be included both in the kernel for the few things that need it and that can be included in any daemons that get written or any user programs. Case point and example is I'm pushing my guys real hard right now to start using DNSSEC. If this is flying over too many heads, raise your hands with questions about acronyms. I won't go into lengthy descriptions of things, but I'll be happy to describe what a particular acronym is. Yes. The question is, what do I mean by crypto library? Do I mean low-level stuff or high-level stuff? And my answer was yes. Can you speak louder, or can we get this more? Hold on a moment. Nils?
Well, I've been discussing crypto libraries a little with Werner Koch, the author of The New Privacy Guard. For those who don't know me, which is probably most of you, I'm Nils Möller. I'm hacking at the moment for on an GPL SSH replacement called LSH.
You're Werner Koch?
No, Nils Möller.
Nils Möller, okay, right.
And Werner have been discussing a little and have had different opinions. But I think in my experience is that what I need is the low-level library. I want the simple black cryptos, hash functions, and big nums and stuff. Then I want to build that abstractions I need on top of that. And my experience is that if I get a fancy library with its own high-level API, that API most likely doesn't fit my application. Mm-hmm. Therefore, if we do the crypto library stuff, it's nice to build one or several high-level APIs, but we need a low-level as well. At least I do.
I'm going to try to take notes because this is serious stuff. This is a technical session, as I keep saying.
We're not scared of.
Well, I'm really amazed. I have to say, I'm really amazed and pleased at how many people are here. I don't know if this is just a theater or if you're all planning on doing some hacking or something, but there's quite a lot of people here. I was expecting more like 20 or 30 people. Instead, we've got more like 100, and a lot of you standing. And thank you for caring enough to at least stand and watch all this.
So I have a question. How many of you, just raise your hands, have read parts of the Linux kernel source code?
Whoa, it's working. How many of you have contributed even as little as a line of code that's ended up in the Linux kernel? Linux distributions. Any code that would be a Linux distribution. Okay. All right, everyone else who didn't raise their hand, clap. All right, so by low level, you're talking math functions, big nums, the whole bit like that.
Primarily things like symmetric things, hash function, block cryptos. I want low levels, I want simple structs, simple defines for key length and stuff, and simple C functions that takes the same structure and parametrics.
Okay. Would you consider implementing, say, triple des? Would that be too high for you? I mean, what I need now is I need triple des. My team, I should say, needs a triple des. Well, we've got a triple des. We've got various things, but you know, there's this problem with the libraries. Right now, there's a whole bunch of we're arguing over the granularity of the functions we need. Okay, and that's nice. That's a great technical argument. I actually know that there's a lot of libraries out there, but most of them come with some sort of whacked out licensing. They don't have the Berkeley licensing, they don't have the artistic licensing, and they certainly don't have the GPL licensing. And really what we need is all the crypto algorithms anyone can imagine in GPL licensing in a library that we can include that's got both low-level access and high-level access to these crypto functions so that we can get people optimizing them so that they can be included in any Linux distribution. Any of those three licenses would do. You had
Talking about low-level libraries, I mean, they're out already. I don't see the point there.
The,
I mean, talk about, well, just because I'm at this point, sorry, I mean, you can improve already, but I mean, to solve it, I mean, they're all good, and
yes.
Free check it.
That's right. That's what I do. I used available implementations to public domain and things. I think I wrote RC4 by myself, but that's trivial. So the thing, if you want, it's more than code. There's some stuff around it. You need autoconf stuff to figure out word sizes and I try to get indenness and that sort of details. And you want to have it, these things, you want to use them, collect them so that it is consistent. You also want a fairly consistent set of functions. For example, I want the state struct, the length, the data pointer, and the convention should do, but it's a good thing to have the same convention for all log ciphers. And that's the point of putting it into a library, to get consistency.
Consistency also, in my work with Linux FreeSwan project, I have found a pile of libraries out there in my looking, and I'm certain I've missed some or something like this, right? But I haven't found one with a GPL license. If you right, and OpenPGP, I can assure you, doesn't implement some of the algorithms my team needs this week. They,
Just for an example. It's just an example. I mean, but
they have some pieces, right? I've talked to Werner Koch about this stuff in email, and
when you're talking about email, just talk about basic stuff. How you just plug it into your system. You were talking about Blowfish, about triple S, just drivers, low-level block drivers, block ciphers. The MD5, I mean, the MD5 still has bugs as far as I know, because you're just a Futsi engine. So it would work on Spark. Well, anyway, doesn't matter.
As for the new privacy guard, I've looked at that code, and I think it's pretty good code, but the API is too high level for my purpose. It has its own object system kind of thing, its own lookup of algorithms, its own dynamic load interface, and I don't want that, because that doesn't mix with my thing. I want to do my own abstractions about it.
are any of the OpenCA people here? Shoot, they haven't made it up from Italy yet. I guess it's a long drive. Is anyone else here who's actually doing, like the two of us, although I'm an American, so I can't code, right? Actually doing crypto projects? Okay. Let me ask other people at this level, low level of libraries and stuff. Are you running into any problems? Would your implementations have gone quicker if you just had the pieces laying around? Yeah, and SSLEAY does not have a GPL license. Okay. Others?
With the Chaos project, and we have the same problem that most other people have, namely that we can't write crypto stack in the United States, that we can't use crypto stack in the United States, and so we are currently forced to practically re-implement everything. One of the Israeli people is doing that. A lot of this work wouldn't be necessary if the crypto code were available outside of the United States and under GPL or another open license.
You may
Keep the mic.
okay. You might want to have a quick look at LSH and see if the GPL code there suits your needs. It has some things, and
Well,
it's at least I thought about making it independent of LSH, but I haven't got around to that yet. That's similar to Werner Koch in New Privacy Guard.
Yeah. Yeah, I think that one of the things that's happening here is we're all having to rebuild parts of the wheel. And unfortunately, we're all getting the diameter of the wheel wrong. And then we put them all together in a Linux distro, and we've got 800K of loaded crypto algorithms, which are different when 30 or 40K should do the trick.
You get terminal inclusions of include files if you use the IPsec patch and
Oh, great. I hadn't run into that one. So how does this get solved? Is there someone who's interested in this piece? Can we get, you guys at Chaos to contribute some algorithms, and you guys at Alsace to contribute some others? I can't do this work, people. I'm an American. My government thinks I'm too good for you. Okay, so we need people to step in here and look at this. What would be especially nice, actually, is for people like you to email to somewhere. I don't know where is a good spot where we can all communicate. I certainly can't host a list in the USS of A. You can host a list? Okay. All right. I think we have enough people to solve the problem. We need to start arguing over requirements docs, and then some lucky sod who decides they need to solve the problem gets to ignore them and implement something. I mean, isn't that the classic way it works? Yeah. Not if it's MIT Kerberos.
It's not MIT Kerberos.
Okay.
KDH Kerberos. It's KDH Kerberos and
Yeah, I think we're not so interested in protocol level stuff. Yeah, it is crypto coded. Okay. So there's another source. So it sounds like there's a few different places to mine crypto algorithms from. What needs to be done is we need an idea of low level and high level access to generic crypto, which I think should show up fairly quickly once all the people say, well, you guys need this sort of low level and my guys need that sort of high level. I don't think there's really a lot of collisions there. It's pretty simple. I've got math, I need to feed bits into it, sort of thing. So that leaves actually somebody getting excited to do all this. I do need to point out that some of this stuff needs to live in user space, mostly in user space, but the same library needs to get parts of it loaded into kernel space, because there's no reason to have two separate libraries. The crypto work is hard enough to get right in the first place, let alone to optimize it. And things like IPsec are in the kernel. They have to be, because they're dealing with real-time packet flows. You in the back and then up front here. Test files for the crypto library. Okay. And hopefully someone else, so that someone's not suckered into doing too much of this work.
There's just one more detail. I hope I don't bore you to death, but low level, in my world, also has the features that there's no memory allocation. The application allocates the state tracks and stuff and calls functions, but the allocation can keep full control of memory allocation. I think that should be good also when you try to use it in the kernel.
Okay. Other bits and pieces that people want to throw out. I'm taking notes. I don't know if I can ever let you subhumans outside of US see them, but I am taking notes. I know it hurts to say that stuff sometimes, but I'm glad you're laughing. I just hope that it annoys enough people, certainly embarrasses my government into sometime becoming a government instead of an empire again.
Hugh, you're going to see these as an add-on to the existing Linux distributions, that you can go get one big mega tarball and add it to Red Hat, add it to this, add it to that?
If you have to, yes. but I don't want to see that. I want to see when I want to be able, as a U.S. citizen slave unit, to order a disk from Europe, and it arrives with the latest version of Linux. All the crypto's already there. It's all pre-compiled. If there's a new crypto widget out there somewhere, I can just download the source code for it, and it knows it. You know, its autoconf goes, oh yeah, you've got the crypto lib, or it goes, nope, you don't have the crypto lib. Go get it.
Well, others of us are too lazy to order from Europe, and we're going to walk to downtown Mountain View and buy it at the Printers Inc. and FTP the package that
we can FTP it. We can get it, however, but you know, the guy on the street corner who's been told that Linux is the best way to run your small online business, he's going to buy a CD. Okay, and we want to be the best online business platform. Otherwise, Microsoft will claim the high ground, and whether or not they do it, they'll get the sales.
Have you talked to Sousa or anyone in Europe that might be able to do that?
I'm trying. I haven't talked to them extensively because we weren't at 1.0 until April. We're at 1.0. We're working on a 1.1 now. There's a horrible bug with 2.2 kernels, and there's a horrible bug with the fact that all the networking in the Linux kernels is going to get blown away yet this year. But that's all future stuff. Yeah, I'm trying to talk to them. But you know, I don't want just our stuff in there, because that's not enough. We need crypto everywhere. We need it in IPsec in the kernel. We need binaries that are signed, so I can have multiple signatures on a binary. I want to be able to do things like when I'm the root shell, I want an environment variable in my shell that goes, unless this binary is signed by one of the matching secret keys, you don't run it. You just don't run it. That binary is verboten. Okay, it's evil. Don't touch it. We need the libs for user space. Part of the work here, and folks, this is extensive. We're going to have to rewrite all of the shitty little utilities. They all have to go. Telnet, FTP, SCP, RCP, RDate. All of these things are going to have to be rewritten to take into account crypto. And there's a whole bunch of cool work in there. And as long as we're at it, there's a whole bunch of things that need fixing. We've got things to do, like including the latest binds, so that we can have DNS security, so that we stop getting our pages spoofed by people. Yeah, you're doing all that.
Finish first.
What?
Finish first.
Finish. I was running low on things, and I'm running low on voice, whatever.
Seven, we probably have to rewrite all these little utilities. That's the point where I disagree. Where I also disagree on the chaos list. Because I don't believe that code rewriting that's absolutely necessary is a good thing. I think we should, if in any way possible, put the things somewhere where it doesn't require the code to be rewritten. So if we have a secure IP connection, there's no need to put an additional crypto layer in the FTP protocol.
No, that's wrong. And I think I can back up my point fairly straightforwardly, and that is, in the future, we're going to have this resource called IPsec. And that is, we're going to have public keys and private keys, negotiated tunnels, and all that infrastructure laying around, so that instead of handing out passwords and running them in the clear and then just encrypting the tunnels and hoping that cuts it, okay, which it doesn't. All right. What we can do is extend this infrastructure that allows us to negotiate secure tunnels out into user space, so the user can type in a passphrase to much like in SSH to enable a crypto key, which FTP can then use using IKE negotiation between the two ends to authenticate itself to the other end. And that requires rewriting all the utilities, and it's well nigh time for that sort of thing. It also requires designing the APIs to do all of this.
It would be nice. It would be nice, but I don't think it's absolutely necessary at this moment.
Oh, no, it's not absolutely necessary this moment. I want to get some sleep tonight. But I'm trying to give people an idea where things need to go. And we need to start putting the tools in place to do this sort of thing. Because it's going to be hell out there in another year. The script kiddies are getting their act together, and they're getting more and more vicious as they try to prove they're the coolest kid on the block. And there's more and more bad guys out there that are actually using this stuff to break in and find things.
So I'll point out at this point that crypto does not solve the script kiddie problem at all, right? The number of vulnerabilities, for example, in the last little while that CERT has come out with, sorry. If you look at, whoa.
It's loud for me.
If you look at CERT advisories over time and you graph how many of them would just be not have happened had strong crypto been available since the beginning of time, and it's 20-30% at absolute best, and it depends how you count. Most things, it turns out, are still buffer overruns, right? Even this last year, more than half of the CERT advisories were from buffer overruns, okay? What have we learned since the internet worm? The internet worm was, what, 11 years ago now? And oh yeah, looks like it's party time. What were the problems the internet worm exploited? We had passwords that were easy to guess, we had buffer overruns, we had transitive trust. Which of those three problems have we solved today? Okay, so we had trivial, that's a specific problem in something, right? Okay, the Sentinel problem.
Sentinel gets its own class. And it's definitely the class bad boy.
Okay, so basically we've learned pretty much nothing in 11 years about computer security. And this is, I mean, important to me. I study computer security. I'm a researcher in computer security. And it's always disappointing that we in the research community have all these great protocols, all these great systems. Look, we can throw all this crypto at it. We can design hardware that has special permission bits in it, but no one uses any of it. I mean, it's always so disturbing to us. But so this is a danger you have to keep in mind when you're saying put crypto top to bottom. Really, it's not crypto per se that we want. We want security. Crypto is one tool that we can use to achieve security, primarily over networks or across breaks in your trusted computing domain. But there are many other things you have to do to get security when you're not talking about breaks in your trusted computing domain, or separations in your trusted computing domain, rather. You're talking about when what you called your trusted computing domain is compromised. And does anyone not know the concept of a trusted computing domain? Okay, good.
No, I'm going to back up. How many people in the room really know what a trusted computing domain is? Raise your hands. Yeah, I was afraid of that.
So that's the other way around.
Folks, this is serious stuff. Security is not a place that you can just get by like an American and be quiet when you don't know what's going on. Why don't you give a quick explanation?
Okay, so the trusted computing domain is something that goes way back into the annals of military security. And the idea is that you design your system and you pick a certain part of it that you just have to assume is trustworthy and cannot be compromised by an attacker. Then what you try to do is build up your system so that, assuming that indeed your trusted computing domain is safe, you can derive the safety of the rest of the system. Okay? Traditionally, the trusted computing domain was often whole networks, whole, say, buildings. Recently that's moved. Now trusted computing domains are more on the order of your desktop machine, right? You have a desktop machine. I don't care what variety it is, if it's running Windows, if it's running Linux, if it's running your most favorite secure OS. If somebody else has physical access to that computer, you're pretty much toast, right? If they can remove that computer and put another identical looking one in its place with software they have installed on it, then you're toast. Whatever security properties you thought you had are just not there anymore because you're not touching the computer you thought you were touching. Okay, so there is a move to even move away from trying to get from having to have your desktop machine in a trusted computing domain and move towards things like pilots that people tend to carry on their belts. It turns out it's possible that if you trust your pilot, you can still do a fair amount of things on a totally untrusted computer sitting in one of those internet cafes. And that's interesting stuff that we know how to do today, but no one does. But more to the point, if you don't even think about what your trusted computing domain is, you're in even worse shape because you're trying to solve a problem you haven't stated. Right? If the answer is 42, what's the question? Okay?
That'll take about 7 million years of research. You're all set.
Right? So just saying, okay, we'll just throw all the crypto in the world at it, you haven't asked the question yet. You have to say, what is our trust? What do we trust? What happens if that trust is broken? Right? So what is a buffer overflow? It's basically a trusted program that turned out to be prone to attack, right? So if you even do this signed binaries thing, root can only run signed binaries. Signed binaries can have buffer overruns, right? Just because they're signed. So there's more to security than just adding crypto. And crypto can solve maybe 20, 30% of recent vulnerabilities, but it does nothing for the script kiddie problems, which for the overwhelming majority of the problems are still buffer overruns.
Could you then... All right, Ian, thank you for chastising me. Now, apply everything you just said to this evening's conversation. What should we do in that context? Not bother writing crypto libraries for Linux and go off and study how to make our Palm Pilots critical to booting Linux?
What do you want to happen, right? What is the end result you want? Do you want to have PCs that you can say, as long as this PC is trusted, I'm safe? Do you want to have PCs that, even if they're broken into, you're still safe? What does safe mean? And in general, I think that's no two people. Well, okay, we have lots of people in the room. So there will be widely divergent opinions, and not just opinions. There will be widely divergent true answers to this question, depending on your needs. Right? Some people, they don't, if you ask a random person that's running Windows and you tell them, oh, it's all insecure, people can do this, don't download arbitrary programs from the net and run them, they'll say, what, they're going to read my email? What do they have on their Windows box that they care about? Obviously, to us in security, we go, yeah, that's not the point.
I can start answering this, right? My project's goal is to provide network layer security such that when two boxes communicate, there is no reason to expose anything that would allow you to truly break into the machines or to know what's being communicated, other than at such a time a packet of such and such a size went between these machines. Okay, that's what my group is doing. What I'm trying to push here is I'm trying to get it so that my group has the tools at our feet. Part of the problem here I see is we are all of us doing crypto in GPL or Linux land or something like this. We're all having to build all of our wheels and roads and stuff like that from scratch. It has been pointed out our roads collide. right? And they don't work well. I'm trying to get the various pieces just laying around in Linux space, such as anyone who wants to do a GPG clone or fix the horrid mail front ends we have now for encrypted mail doesn't have to go, well, let's see, now how do I build a road? The roads are there, they start using the pieces. I'm trying to get the pieces laying around. You are next. Chaos.
Yes, we have different goal. We're not so much concerned with network security. We want to build the machine sitting in front of you that you can trust. So the layer is different and the tools.
But they're two totally different things. And I think for that problem, you'll have much less emphasis on crypto per se.
For example, we're looking for encrypted file system.
Why do you need encrypted file system if you trust the physical?
Because they don't trust the people who come in and take the computers.
Right. Okay, so but you just changed what your assumption was, right? What is your trusted computing base?
The idea is that if you have an encrypted file system, you have two additional safety caches that you don't have otherwise. One is that if your machine gets stolen, the data is, if the encryption is good enough, pretty much useless to everybody. And the other is that to get the machine up and running, you need to enter a password.
Sure. Okay.
So that's an additional safety for you to make sure that the machine you're sitting at is the real machine that you left yesterday.
Right.
Well,
So
I mean, you can copy a password file to a new machine. It's pretty difficult to copy a whole encrypted file system. Changing it, or changing the process.
well, totally different file system.
Yeah.
Right, so this just underscores the point that you need to state your threat model explicitly, right? Saying that your machine can be trusted is not sufficient or quite accurate if your threat model includes people coming and stealing the machine. If they have physical access to the machine, you have to do things like encrypted file systems.
You have to do things like encrypted file systems that not only authenticate you to the machine, but authenticate the machine to you, right? And depending on what your threat model is, that second one is more or less important, is more important or less important. Certainly the primary use of cryptography is basically to send secret data over a non-secret channel, right? Fundamentally, that's what cryptography does. It allows you to take two endpoints, both of which are trusted, and send information between them through parts of physical hardware or the air or some other kind of network or data flow, which is not trusted. No, it's the same. It's the same principle, which is that I want the data that originated with me and I put on the hard disk when it comes back to me to be unmodified, right? So you are the trusted computing, the trusted endpoint, right? You're not a computing base anymore, but you're the trusted endpoint. The data flow path goes through your hard drive, and you want to say that if it is the case that my physical hard drive is not part of my trusted computing base, then I need to use some kind of crypto from one endpoint to the other. And you're going to have, if you think about it, just do the analysis here, it turns out it's not enough just to have an encrypted file system that you can type a password in, because what if I take your machine, if substitute it with another machine that should behave similarly, it'll accept a password when you boot up, but it'll accept any of them, right? It'll accept any password, and it's just a no-op. And it just produces a machine that's behaving similarly. You can't do the crypto in your head, right? This is one of our hardest problems, right, in the security world is in the particular problem of authenticating a machine to a user, right? Because you want to use crypto, you want to use digital signatures, but the user can't check the digital signature in their head. So they have to use a machine. And now you have a problem. And this is where the Palm Pilot solutions tend to come in, where you can have a smaller machine that all it does is check digital signatures and hashes, and you can be more sure of its security. But
Don't go to sleep tonight. I know which tent your Palm Pilot will be.
Yeah, no, is the message plus Triton, or because the point is, okay, Triton makes the operating system of the thing, and it's not open source, and we can't easily replace it. So how can we?
I'm using the Palm Pilot as an example of a portable token. You need. That's right.
In the open source world, we don't have.
That's always the case. You need a trusted computing device of some kind. If you don't have one, at some fundamental level, your problem is theoretically unsolvable. That doesn't mean it's practically unsolvable, right? You can make things hard to break, and certainly just doing an encrypted file system makes it much harder to penetrate the system. But it doesn't make it impossible. It would not get quite possibly a military A1 rating if they still did that sort of thing. Okay, that's going.
We've got a couple questions.
Got a couple questions?
White.
I think it's quite possible to achieve any authentication that the machine authenticates me because as long as the machine can be broken into in some way. Because the best thing you can do is place a secret key on that machine. But if someone replicating root permissions on that machine would get to the secret key anyway.
Okay, so you've made a couple of assumptions there that aren't quite warranted. Your point is pretty well taken, but for one, you mentioned root permissions. I'm not talking about in general a specific Unix or Linux-like system, right? It could be this is in hardware, for example, right, where you have the hardware authenticating itself by doing a checksum over its BIOS and over its firmware and telling you and proving to you at boot time that its boot sequence has not been altered. And then you can get into the encrypted file system, right? Because I don't care if you have an encrypted file system if I can mess up your boot sequence and do stuff to your computer before the kernel even boots, right?
In the boot sequence before your secure kernel comes up, you're toast.
Right, so these are the kinds of problems we have. And they're hard.
We have another question. You were
Yeah.
next, sir.
Just putting it together, I mean, all you're discussing is crypto is necessary but not sufficient, so we can back to crypto, so we do the necessary stuff first.
Right, okay. Crypto's necessary but not sufficient, but
What you're saying,
right, yes.
Won't solve all problems. Fine, we know that now, I think. Yeah. So we should get back to getting the crypto fixed, and then we can think about the other 70% we have missed.
So now you can 30% and let's do it right now.
Okay.
30%, and that's expected.
Well, fine. Do you have anything else to say?
No, that's good. We can go back. Go ahead.
Token.
Doing some kind of USB blocks like the Apple to authenticate your machine.
Oh yeah, there are people talking about that, and I bet you that the poor Microsofties are going to see a nightmare in USB dongles hanging off the back of their machines, because it used to be you could fit 1 or 2 dongles on the back of a machine, maybe 3 if you had a parallel port dongle doing security things and screwing up your ports. Now you can have 256 on a machine, 1 for every piece of software some commercial company wants to control. Oh joy. All right. Yeah. Eros is not finished. Eros is much closer to the right way to do computing than Unix is. I know because I'm the guy who introduced the guy who wrote Eros to the concepts that back up Eros. So I'm quite familiar with this stuff. The thing is that I'm not going to get. Okay, here's the question. Because I tell you, how many people in this room tonight are willing to wipe their Linux boxes and put up Eros? Okay, 0, and that's as it should be. Okay, we've got to fix Linux, if for no other reason than Linux is becoming a snowball and it's rolling down the mountain. Okay, and it's going to get bigger no matter what we do. I've been doing Linux for about 3 years full time. Before that, I believed the FreeBSD was a better OS. I still believe it is. I also believe that in the next year, if the Linux community works hard, it will be a better OS than FreeBSD. Right? I've got to fix what's going to get used. At the moment, that's Linux. Okay? Okay. So we need a Linux library that is useful. We need to spec it out some. I don't think that's something that can happen here. What other pieces do people need to get these systems forward? Is, for instance, do we need public key stuff? What else is there? Grab the mic.
For me, there are 2 big things that are missing and that I don't know from where I will fill them. And the first is host authentication. Again, my perspective mostly buys from SSH style things. And the big problem with SSH is to authenticate the other host first time you connect. And it would be great to have some kind of infrastructure that you get the host key from a secure DNS or something like that.
Okay.
I don't really know the alternatives.
Secure DNS is somewhat a solved problem at this point in time. Bind 8.2.1 and maybe. Okay. Don't trip down the dark holes out there. Especially if your name is Alice. DNS is out and available. Secure DNS is built in to the current binds. Are there any SUSE representatives in here that can tell us whether or not they're going to be including bind 8.2.1 or later in their next release?
Well, I hope so. I don't know who's maintaining currently, so I can ask Florian if the new bind version will be included.
Okay. But they're out there. The tools aren't all that great. And actually, the biggest hole in using bind at the moment is there's no documentation, even at the how-to level, of how to use secure DNS. You get all the bits and parts and pieces for generating SIGs and key records and putting them in your data and the whole bit, but you don't know how to use the pieces. And when you try to ask the pieces for minus help, they kind of laugh at you. So there's a task there, which is just someone sitting down figuring out how it works, which probably means a combination of looking at the new stuff that ISC has written and also looking at the crap that TIS wrote and trying to figure out between the two of those what the right thing is. But there's another whole task that is actually kind of small, kind of manageable, and isn't even directly computer programming, but it's critical to getting this stuff used, which to me is becoming as important as getting it written. Does anyone have a Roto-Rooter? I think I need it for my throat. No, it's Coke is Pepsi anymore. There's no difference. Whatever. So the next question for me, at least on my list, is APIs. In that there's a bunch of different layers that APIs need to be done at. for this stuff. There's the low level stuff. There's some mysterious higher level stuff. How many people that are actually writing crypto code need RSA and stuff like that? Oh, okay. I want to see the following. RSA has pissed me off. All right. One NSA dude joked in the US one day that if he really didn't want me to have a technology, he'd license it to RSA. So one of the things that would be really cool to see is on August 20th, I think it is, in the year 2000, September 20th. Yeah. If Linux had all the RSA code you'd ever want, and you never want to use their code or license anything from them again. How many people here need that sort of stuff? RSA, DSS. I know I need DSS. I know I need RSA for our Ike daemons. How many other people need that stuff? Does that go in the same set of does that go in the same library? Has symmetric algorithms and hashes and stuff? Yes? Okay. Blowfish, Twofish, and the other AES candidates, are these things that people are beginning to use or would use if they were available? You would say wait and not include them?
I don't know about including them. I would not recommend using them at this time. I mean, all these candidate algorithms are very, very new, and it's a little bit foolish to trust any of them right away. We have good algorithms right now that their main problem is their limited block size. The main problem with the limited block size is you can only send so much data with the same key. For most protocols, that's not an issue at all. So for most protocols, the block ciphers we've got now, even if you really care about block length, go triple mode like triple des or something like that. 168 bits is fine. Unless you really have to encrypt lots of data with the same key, use triple des and if speed isn't too much of an issue to you, desx if you like speed. If you need stream ciphers, we can mumble about RC4 about whether it's actually legal to use or not. Yeah, I mean, as you said, license something to RSA and it just becomes impossible to even figure out if you're allowed to use it or call it by its name or reference it by, right? As far as anyone can tell, it's legal to use RC4 as long as you don't call it that. Really, that's a ridiculous situation we're in.
Okay, it has an alternate name, ARC4?
Sure, and some people are calling it ARC4. I could see RSA's lawyers taking you to court over that, and they're bigger than you are. Of course, I can see RSA. They're bigger than you are. I've seen their lawyers. Yeah, I mean, there are all sorts of... We have two problems to fight in the US, which is not only do we have the export controls preventing us from getting the software out of the country, we have the patent controls and intellectual property preventing us from using it in the country. And
I don't give a flying hoot about U.S. citizen slave units. If we have to go to the way of the dinosaur in the U.S. because we're stupid, fine. Okay, I need the tools built for the people who are bright enough to use them. Okay, in the U.S., if it comes with RSA and RSA won't license me the product to use inside Linux, then RSA is just going to have to hunt down every single person who's breaking their license with those nice big lawyers you just described. That'll keep them plenty fat. All right, I don't care about that. I care about getting the problem solved so I can set up a Linux box in free countries like Amsterdam or Tonga or something like this and run them without worrying about, are they going to get broken into every Tuesday? Okay, when I'm in the USS of A on my laptop, I'll have to remember not to call it RC4 and use its alternate name on the command line or something crazy. That's people in the USA's problem until they bitch at their government and fix things. Do you understand the attitude I'm taking?
Sure, I'm just skeptical that you ought to put bitching at the government in your critical path.
Fine. It's out of my critical path. I won't bother. Let's get some work done.
I think the last point was we need all the new algorithms, and I think the answer seems to be not really. I don't know anybody serious who really wants to use them. So, okay, for playing around, maybe Twofish or something, but I don't think it's a high priority.
Hold on, you're two. Maybe my burp was one there. The algorithms need to be in there, in my opinion, or at least Twofish, because they use completely different interfaces in that the size of the bits, the size of the cycles, various things like that. And there's no reason at this point to start embarking on building tools that don't handle the tools of next week. Yeah, they don't deal with the stuff from next year. We don't know what that looks like, but next week we have an idea if you live in weird timescales like I do. A couple of people were up. You were, sir.
Blowfish, yeah. No, I'm coming
So
from
you
Blowfish.
Blowfish is free, and it's annoying thing in the United States, maybe.
It's free. I know Bruce. Bruce is a good guy. He might be a salesman, but he's still a good guy. Okay. And also we have to remember this here is an academic crypto scientist, all right? And nothing is proven secure until it's been broken, okay? Okay, for instance, if you were to follow Ian's advice, you would never have implemented DES because it's not proven secure. Or it's not broken, right? It came out as the standard. Just because the Fed blesses something doesn't mean it's good. Matter of fact, I might look at the 5 candidates and go, whichever one the Fed doesn't bless, it might be better. So I'm perfectly willing to have any of the AES candidates that have declared themselves publicly available in there. And the public availability is crucial, in my opinion. Now, I should give you time for rebuttal.
No, we have another question.
Next.
Okay.
Are you first?
About different algorithms. There was a discussion at IETF a few weeks ago about whether or not IETF should require another algorithm besides triple DES.
I was there.
Do you think that is anywhere relevant to this?
I actually personally don't think any of it's relevant. As far as I'm concerned, triple DES is good enough for now. We understand its security well enough to use it. I'm concerned that the tools we build handle the larger data paths of various sorts that AES candidates need. My proposal to IETF was we just put in all the AES candidates that have declared themselves to be publicly available and not licensed. And I think that's like 3 of them. And that's fine by me. You see, partially what I'm after here is I'm trying to get a vertical stripe of problem space solved. I want the Linux Free Swan to solve one of every problem from top to bottom so that there's a path through this maze and you can get the job done, right? And then, anyone out here who's bored some night can implement, Twofish. Might not implement it right, but, that's what the next night is for. Okay, and then you can, send that code out, GPL it, get it added to the library, and then all of a sudden that vertical stripe becomes a little bit wider. But what's happening now is we can't get a vertical stripe all the way across the problem space because there are too many bits and pieces that are missing. So personally, I threw out the AES candidates out there for discussion, not because I feel I need them in my team's work.
Is there a GPL version of an X509
Yeah, the crud like that. That's why I asked if the OpenCA people were here from Italy. They sent me email after I asked them to come to whatever this is. Where are we? HIP, CCC. Is it HAL 2001 yet? And I presume they're just going to arrive here and it's the long drive up through Italy, or the tunnel collapsed on them, or they all got pushed out a window. So there are people working on this. They should be here yet this weekend. If you find one of them, send them my way or talk to them yourselves. It is being worked on, and we do need that piece.
Okay. I'm kind of bored with symmetric crypto. I just use triple DES all the time. I don't
That
trust.
is symmetric crypto.
Yeah, I'm bored with it.
There's nothing to be argued about it.
Yeah, I don't. It's not important, but I don't trust public key crypto. I think they're probably going to announce the final factoring algorithm at Santa Barbara right now, and it'll be gone with. But I'm more interested
Really?
in. Yeah. How do you know they're not?
Okay, who's willing to do a one-time pad cipher?
No. I'm more interested when you mentioned ideas of checking certificates, of rewriting all the little utilities and things. What you're thinking there is a road, because I've never heard you mention that before. I've never read about it on the net. Or
Oh, well, yeah, but I have to have a public forum where I'm free to speak in, remember?
oops.
This is that. I've been working in IPsec for a long time, and what it provides us is DNSSEC, IPsec. We start having an infrastructure that has crypto keys all over the place and is doing crypto negotiations between separate entities, between separate machines, etc. I see this as allowing us to rewrite the utilities that currently cause so much pain. Ian was saying that the script kiddies aren't breaking in because the crypto is bad. They're breaking in because this utility's got a buffer overrun, and this utility needs a clear text password, and blah blah blah. All of that's got to change. Okay, we've got to get rid of these utilities. I mean, for God's sakes, anyone here who runs a secure Linux box, does inetd do anything? you just get rid of it. No, it doesn't, right? And then you got to backfill in SSH, but SSH doesn't actually communicate or share keying information or identity information with IPsec, which doesn't use the same identity information as the password scripts, and all this stuff is kind of fragmenting. And then if I try to take some poor secretary and say, well, you need a password, a passphrase, not even word anymore, passphrase for SSH, you need a passphrase for bin password, you need a passphrase for your IPsec permissions to talk to this machine, you need a passphrase for your PGP mailer, you need, and what happens is people all start using their birth date again, right? And we're right back where we were in 1987, when the best way to crack things was to throw dict words at it.
Pam is confusing the hell out of me right now, but is it a step in the right direction towards
What
that?
is?
Pam?
Pam?
P-A-M?
Pam? Oh,
Never mind.
I never.
If you don't know,
use,
never mind.
Yeah, no, I never use it. I mean, I get it comes up however Red Hat configures it. Does anyone do anything with it?
I haven't figured out how to turn it off, but
I haven't figured out how to turn it on, but it's not a pretty Red Hat.
Three things. First, Hammond will probably be part of the next chaos release. We're working on that. So hopefully you can try it out. The other thing is, I'm still opposed to rewriting code if it's not necessary, and I believe that problems should be solved where they occur. So, for example, there are several solutions to the buffer overrun problem, like electric fans or stack guard, all been around for years. It's just not. I don't know whether they've been updated recently. I think not. I think none of them have yet ported to EGCS, for example. But that's the solution for buffer overrun, to make them possible. Because no matter how well we write the code, some buffer overrun will remain. So if you've got to disable that.
Well, how many people are familiar with the tools he just described to deal with buffer overflows? Not enough. Could you talk about this for a moment?
And the basic idea of stack guards, for example, is that it puts, in addition to the return address that you try to override with buffer overrun, it puts some kind of mark on the stack, and there's code in the compiler that makes sure that this mark gets checked. So if you try to trash the stack, you must trash the mark before you trash the return address and before you can insert your malicious code. So the mark is missing, and the kernel, or I think it's the kernel, finds that out and refuses to execute this return or whatever statement there is, and just kills the program.
Is that a good enough solution to the problem, Mr. Academic?
Probably a bad description.
No. It's,
In fact, in the same conference, we saw two solutions to this problem, and it solves some things. It turns out it solves a large class of buffer overruns. By solves, it's a little tricky because if someone knows you're running it, then there are issues about, well, couldn't they just arrange to put exactly the right marker in exactly the right place? So you have to have non-deterministic markers and right in the recent release, exactly right. So there are issues involved. It turns out it doesn't at all solve other overrun related vulnerabilities that don't involve the stack. You might imagine if you have an array in a global heap, and after that you have a security sensitive global variable, and that array gets overwritten past the end, and you overwrite the variable. It's simple things like this.
so we have to quit writing in C after all.
I would say so, yeah.
It's not that 11 years later we're still running SynMill. It's 11 years later
We're still writing in C. I believe that's a big part of the problem.
Is not the solution.
But it has a smaller trusted computing base than all that C code with buffer overflows.
Yes,
You
it
can get
definitely
the virtual
does.
machine and the checker. You can start talking in terms of trusted computing
And if you
base,
can
right?
figure out what the virtual table is all about. Yeah, right. Anyway,
What?
It's
Java's a much better answer than C. There is no question.
Okay, you have more to say?
No.
Take the map.
Oh,
First, just three.
First of three. Can you hold on? Well,
That will be short.
chaos reigns.
That will be short. I think one of the problems that you mentioned was passwords. We just set up passwords for about 30 people at our company, generating randomly a letter, stuff like that. Nobody can remember that. Well, they could, but nobody cares to remember them. So, they lie around. Just, I bet if I go home on Monday and just stay until 10 o'clock, like usual, open some random drawers, I find the passwords. So just making passphrases possible, not necessarily with some crypto file system or fancy stuff, just MD5 passwords. Just making passphrases possible would be incredible because people can't remember passphrases and be more secure.
Okay, you still got the stack, but I'm popping you one down. And I guess you're after him. Oh no, you're after him. Okay, 2, 3. Does anyone here have experience using the Macintosh meta password system where it would take a bunch of public keys and you'd have to unlock each one, but then you could lock the whole thing up with a single password when you walked away from your machine for half an hour, and with a single other password, you could unlock it and use it? Never mind. I need to give this back to you. He'll just say something to annoy us and make us work harder. Go on. That's it. Okay, 2.
Well, first of all, about PAM. I like the design goals of PAM, but the API, at least as it looked when I read it half a year ago, is really, really ugly. To support in a thing like program like LSAs, which require massive cladgery. I can expand on that if anybody's interested, but I guess this is not the place.
Okay.
What I want to say is I think it is a pretty simple kernel hack that I would really, really like someone to do.
Oh, thank you for reminding me about that. Gods, yes. Well, you have one, I have one, but he gets to speak before me. I guess I'm 4.
Well, this I also thought when discussing with Werner Koch, because he uses his own hacked GMP Bignum library to get control over allocation of things, so he can try to allocate things in in a non-swappable store and things like that. And I really don't like that, because there's no way for an application to know which data is sensitive. If I use a security program, it's very likely that not only the keys but also the data is sensitive. So that has to be protected. And it's no real solution to turn off swapping of all data in the process.
And I'm going to jump in here because you reminded me, that is when you hit the go to sleep button on your laptop, that's got to propagate to all the applications that need to flush keys before you go to sleep. And the guys at the airport take your laptop from you.
But one thing I want is I want an encrypted swap. And I think that is pretty easy, because the idea is whenever a process is created, you create a random key. And then you use that key to encrypt all writable or all non-shared or something pages when they are swapped to disk, decrypt it when they are swapped in, and when the process dies, the key should be destroyed.
It's automatically lost that way.
Yes, and that should be configured on a per user or per process basis, environment variable or something like that.
Yeah, it's obviously a good idea to do that, and mumble performance go by faster processor. It turns out the hard problem is exactly what you said about shared pages across processes. You don't want to lose the fact that right now you can have one physical page on disk or page in memory actually being the backing for 2 virtual pages. So you would like to arrange now to start sharing keys, and now it can start getting a little hairy. What's that? Oh, no, but if say 2 processes have a shared memory segment, right, and they're using it to pass critical data back and forth to each other, so that's the kind of thing that on the one hand we could put in pinned memory, but if the solution we're using instead of pinned memory is an encrypted swap, then suddenly both of these processes have to be able to access that encrypted swap page. So, I mean, it's just an engineering issue.
To be transparent, the only point about encrypted swap is somebody pulls out the plug and takes away your computer, and everything is greatly encrypted. Only your swap file isn't, because it's swap. Just memory and stuff with this.
You know, the big, hold on.
Don't take anything. Just writing into this, you just encrypt it, read it.
No, stop. We understand this, okay? What you don't understand is that in the old days, there were operating systems that if you had 50 copies of Netscape running on one CPU and something big came into memory, you ended up with 50 copies of the Netscape binary in the swap, okay? And this was murder on systems. And there's an advantage that Unix has had for a while, which is it writes only one copy to the swap. And in actuality, if it's the binary itself, it doesn't write any, it just marks the pages off of the raw disk that the binary normally lives in has the pages it needs to swap in, okay? And what Ian's trying to do is preserve this behavior because it's a big win, especially for, say, incompetent things like X and having 50 X terms out there, okay? That's where it really begins to win.
If you make the encryption transparent to the point that when the swap process wants to write to the disk, at this point it gets encrypted. And when
But
it
what
reads
you
back-
want me to do is have one key per process.
No. Do you want one
He
piece
said,
of
but I don't see why.
That was what I said. You could do different.
That way, when a process dies, its swapped memory is automatically irreplaceable. Whereas if you have one key just for the life of your computer, because your swap file Sure, but say I put the computer to sleep. You can't forget that key, right? If you forget that key, then you can't swap back in everything when your computer wakes up. Right, and then it's just as bad because now I can read that computer out of that thing out of RAM.
That doesn't solve the sleep problem, but if you use only one key to encrypt the whole swap, then it solves the problem that if somebody just pulls all the power from the system, it takes it away from you that he can read the data from the swap and you can't do anything about that.
Right. So it turns out it's not quite true either, but
Yeah, and if I'm bright enough, I'm going to have, and I'm a nasty enough bad guy, when I come to steal your computer, I'm just going to have a little connectors that pinch through your power cable, feed in the right power, and then I'm going to cut the upstream power, and I'm going to take the whole thing away powered.
Okay, but that's a different threat.
That's a very different threat model. You were up next, sir.
Relatively secure method for picking password because these words are usually not in dictionary. So this would be a method to remember passwords.
I'm sorry, what was the first letter of each word
Yeah,
method of
Yeah.
doing it? Yeah.
that's the user identification problem.
That's
This is for the password problem. And second thing about forgetting learning content. I'm one of you guys the ACI and it's not
An API for going to sleep. Right.
okay. So to talk about the first problem, it's actually really, really hard to pick good passphrases. Okay, doing the first letter of each word, that's useful for picking a stronger password than most. But if you want a passphrase that's used to protect a cryptographic key, save 128 bits, if your passphrase isn't 128 bits strong, then you've weakened the security of your system. Okay, so here's the challenge. Get a human to be able to type 128 bits of entropy into a computer. Is Carl here? Carl Ellison? No? He's around somewhere.
He's here.
He's here. He's just not in this room. So he once told me that he uses one of those systems, the single passphrase like SSH add and the SSH agent stuff, or I think Q was describing a similar thing for the Mac, where some daemons remembers a bunch of private keys and you authenticate yourself to the daemon with a passphrase or something like this. And he just, at one point, had a computer generate 128 random bits in hex and just memorized it, right? And he memorized that one. And it's not too hard to memorize 128 bits. It takes some work, but if you use it every time you log into your computer, you're going to learn it, right? Now, that having been said, most people aren't going to do that. It's very interesting to look at how much entropy most passphrases actually get. If you do something like the first letter of each word, letters, how many letters are there? About 5 bits. They don't occur equal probably, though. So you actually only get a little more than 3 bits per character. So if you generate an 8-character password that way, you have about 25, 26 bits of entropy in there. Okay? Now, we all know that 40-bit crypto is a total joke. 26 bits of entropy isn't going to cut it. So we go to longer passphrases. And the hope now is that you don't have to have a passphrase of the form that only makes sense in Welsh. Rather, you can... you can actually have like long sentences and hope that the length makes up for the redundancy. Okay? The problem is it still has to be really long. English, it turns out, has less than 2 bits of entropy per character. So if you're typing an English sentence, it's about 1.2 actually, and you want 128 bits of crypto of entropy in there, you have to have a 100 character passphrase. Right? That's a really long passphrase, especially if you don't get to see what you're typing and you have to get it right. Right? This is a non-trivial problem. So, okay, so what is the fundamental problem here? The fundamental problem is that your brain is stupid, right? It for some reason can't remember 128 bits of stuff reliably, and your fingers can't type them reliably. So what do? Well, we attach a smarter brain to ourselves, and we use a piece of trusted hardware.
You mean your board brain?
Sure, like right here. So it's a very well-known problem. How many people here have a Pilot or a Scion or something like this? Wow, that's a tiny, much, much tinier number than I expected here.
Ask how many people have a smart card in their wallet.
Right. Okay. How many people here have a smart card in their wallet?
Every EC card, every SIM, okay, yeah. So how many are using it? Well, that's a lot.
Okay. It turns out using smart cards has a fundamental flaw in that it doesn't help at all authenticate the computer to you. Right. And if that's part of your threat model, it turns out you can't use smart cards at all reliably. But why? To what computer?
Well, so how does the smart card communicate with you? Over the computer? Oh shit.
There are smart card readers with small LCD displays that you can carry them with you.
Okay.
That's it.
Trusted hardware. That's trusted hardware.
Carry it with you because then you're sure that it's
Right. Exactly. And that's the solution. Right. That's exactly the right solution to this problem.
Except that in the USS of A, you will not be allowed to hold on to that through the magnetometer. Think about it. Yeah. Yeah. Oh, they're setting things up wonderfully, aren't they?
Anyway. Right, and that is exactly the right solution. You have some kind of trusted hardware, but it has to have some kind of UI. It has to be able to communicate directly to you without going through untrusted means. So, right, that is the solution we have to move to. That is the solution we have to move to. Dallas Semiconductor rather proposed these iButtons as a solution to this. It's the exact same problem as smart cards, obviously, but they're useful in certain situations. We have to get rid of passwords. I mean, that's just it. People are just not good at remembering passwords. We have to have some.
And that's where the rewrites can get again.
We have to have some totally other mechanism. Now, remember, there are two major kinds of passwords and passphrases. One that we've been talking about just now to unlock crypto keys and things like this that are stayed locally. The passphrase is never sent over the network, right? And there are the other kinds of passwords that are the traditional ones that are sent over the network. Those are pretty obviously bad, right? Anytime you send any kind of replayable token over the network such that anyone who has ever seen the token in the past can use it in the future to impersonate you, don't build systems like that today. I mean, we have much, much better solutions. And all we needed now is a library so we can use them.
I think there's really a major problem with all the security stuff, and especially crypto, and that's the user friendliness. I mean, the basic problem is all the stuff is really too hard to use. I mean, I had lots of customers, and the really biggest problem is make the user do the right thing. Make him remember his password, don't write it down, all that stuff. Make the user remember 5 simple rules. Takes a big lot of money and time. And going, like, I mean, I've been using PGP for ages, but it was so to explain to people who are interested in it that you just, it's not going to happen. So we need some standards about how to communicate to the user, how to use this stuff.
Have you seen the data key? This is the absolute coolest hardware token I've seen. The idea is exactly the same as an iButton or a smart card. It stores your cryptographic keys and stuff, but it's in the shape of a key. And you stick it in a keyhole and you turn it. Right? And this is just the so obviously right form factor to store your crypto keys. I think it's just data key. Search for data key. That's the name of the product. Very similar things have been in use in the military, like for Stu 3s and the predecessors. Encrypting phones and stuff like this had the same form factor of physical keys you would put in and turn. I believe the N-Cipher products, the NFast boards and stuff like that, the ones that do secret sharing, they use this data key.
There's a reason that I refer to this as cryptographic hygiene, and unfortunately it's as bad as using a condom. Can we have your comments?
Right. Observation on difficulty of using secure products and how to persuade people to use them. I was at the SANS conference in Baltimore earlier this year, and how comrades gave a story about how he'd been forcing his users to use one-time passwords, and they all cried about it knowing, and for months and months they've been usable, but they kind of done it to divorce them. Then one day, one of them comes in and says how he quite likes this thing, and I says, well, that's right. You can tell me you don't like it. Oh, well, last night I was down at my girlfriend's place, and I got a page that I had to go and fix some problem. So I put this list out of my wallet and take the top item of it. And
Thank you. Thank you.
So what you have to do is you have to convince them that there's something meaning about using the right way.
That's a documentation problem.
Yeah, it's a communication problem, especially making it clear to the user what the real benefits are. For example, not giving out your password. That the problem is that somebody can make you suffer by using your password. And it's not obvious to the user.
If you want to see pain, you should have seen the day I cut off the president's account because he gave his secretary the password. Ooh. Would you like to say something?
I'm speaking. I'm speaking very much raw and I must go. Okay. I show. But I have sleeping. That's okay. Yes, what I mean. I am sleeping here. And then he says,
Random noise in the datacom channel. Okay. Oh, someone new, way in the back in the red.
Why are you speaking about passwords or tokens or biometrics?
Well, I never want to see biometrics in our system. That's when we really start screwing up security incorrectly.
Okay. That's an option. I tend to agree, actually, but it doesn't matter. It's a way. Just like tokens are, just like passphrases are.
Yes.
I totally disagree on trying to teach the student, sorry, the user. It won't work. I've tried it. It didn't work for my people. Put it that way. But if you can combine it, then take the weakness out of the password. By the way, a keyboard is a trusted device. Everybody agrees?
No, not. It depends on your threat model and it depends what you're trusting.
If you use a password, then the keyboard must be trusted.
Chaos was next.
Actually. Anyway, what I was trying to tell you is you could combine them.
Okay, hold on. I'm going to strongly jump in here and agree with him, whoever he is, in that one of the things we need to look at when we're doing our new APIs is providing multiple channels for things like this. Another example is, I think we need a new channel besides DNS name, IP address. I also think we need a new non-hierarchical name that we can pass around that's based on the hashing of keys or something crazy, unknown, completely unknown. But that's the sort of thing I think we want to pay attention to if we're going to start redefining APIs. So yes, it's a perfectly reasonable and valid point. One more, and then Peter.
Water is spitting out of it, and it looked kind of funny, and then asking you to give it back to me. Would you like to give your password on it?
No, what I was trying to tell you is when you use your password, you must know your keyboard. And the keyboard is usually not considered to be not trusted. That's the only thing I was trying to say. The other point, the second point I was trying to make is that you're now discussing algorithms for crypto as well as keys, etc. Those are different subjects. There's no reason to do them together.
This is right. This is a crypto summit of how do we solve all of the problems. We've talked about the library tools that a lot of us need. I felt it was time to talk about that. All these other things need to be discussed as well. All right. Chaos was next, I think. More noise in the channel, I noticed. Yes.
About the keyword, about trusted keyboard or not trusted keyboard. Siemens had a kind of biometric keyboard with fingerprints at the CVIT.
Yeah.
And the one problem that the guy at the booth couldn't answer to me is what happens if I just rip off the cable and plug something in between? They haven't thought of that. They just
Raising the bar. This is I had a very similar experience.
And the other issue is with the user education, you can't educate users just on all of them. You can educate some users if they have a reason to protect the data.
And you can make it easier or harder to educate them. That's the problem. And we need to work on the easier or harder.
You just shoot the ones that don't learn. That's the Darwinian solution.
Great, but that doesn't work for everybody.
No.
That's a small note on trusted keywords. The smart card reader I told from the LCD display, and it's very small. It has a very small keyboard.
Yeah, yeah, right.
Okay, like this. Of course, what I would like to see is Palm Pilot with a smart card reader.
Go to the Cypherpunk stand after. We've got one.
Yeah, you got one.
We've got one.
Thank you so much. Can we buy it? How did you export it?
Peter? There's no crypto in the hardware.
Oh, this confused. All identifiers are allowed to export hard crypto. Just for their personal use.
Oh, all U.S. citizen slave units are.
I know all identifiers.
No. All U.S. citizens are allowed to export crypto to bring with them for their personal
But they must bring it back.
Bring it back.
Intact, with the virginity still there. Yeah. Okay. What other crypto-related problems are there in Linux that could be solved by having more tools laying around in Linux? 1, 2, and then whoever else raises their hand, go.
Other implementations for some kind of getting even better randomness. Like,
Go read the Linux IPsec list. It's been the topic of discussion during the month our other bug has gone nowhere and being fixed. There's a lot of work going in. Oh my. Will everyone please, is that the moon? Astronomy break. Let's all look at the gorgeous moon. Cool. Okay. You just asked, Martin. No. You just asked. Randomness. Okay. Randomness. Here's the situation there. Theodore Cho, who is the dev random and dev urandom author, is now working on Linux exclusively. He is no longer working on the uneducatable MIT students. He's been hired by VA, whatever their name is this week. Well, it's no longer VA research. It's VA, whatever the name is this week. Much like there's Hardware Corporation Canada, whatever their name is this week, et cetera, et cetera. There's a lot of talk about how to improve randomness. I expect you'll see a randomness user library extension that uses different sorts of randomness that can be produced by the hardware, because what I'm seeing is that there's some things you want the hardware to do, or some things you want the kernel to do, and a bunch of other things you want, but you might not want them. So put it in a library, let the target program use it. There needs to be probably a cheap random number solution available for machines. The Pentium 3s, I don't think the first batch of them, but the newer ones have a hardware random number generator in them. Well, and a serial number, but it's a little odd. Right now, John Gilmore has been trying to get Intel to release the information. Intel, being weird and psycho, has said, yes, we'll give you a machine to reverse engineer it, but we won't tell you how it works without a non-disclosure, preventing you from writing code to let Linux exploit it. It's absolutely true. They'll give us hardware and let us reverse engineer it. They won't tell us how it works. That having been said, I would much rather approach AMD, say, hi, let's design one for you, and these assholes at Intel can go to hell. If they won't do the tools right, let's not give them money to continue screwing up our lives.
Again, I wouldn't put that in your critical path.
No, it's not. Okay, so that's the randomness situation. Randomness, unfortunately, is especially bad in one place, and that's machines without users in front of them, which is exactly the classic machine for what my team's designing for. All right, so a small hardware random number generator project that can be built for $20 would be nice.
So as we say in academia, that's a known hard problem.
Doesn't Red already like that up from other hardware activity like hard disk?
Oh, it gets it from SCSI disks, but not IDE disks.
And it turns out, right? It turns out that it doesn't matter anymore because RAM is now getting so cheap now that the U.S. government's out of the business of screwing up RAM prices that you're not seeing head float or head timing data in even SCSI disk information anymore because it's all been cached and it's gone.
Yeah, but especially like on a certain machine that has to track it pretty much, right?
Well, you know, I propose. Yeah, the problem is it's externally influenceable, and you know what's the whoa, nice, whoa, not only nice but bright. Influenceable but not controllable, and I'll let you have that debate with Theo Cho. All right, yes, I will repeat the statement. Randomness is getting better. It would be nice to have a cheap hardware solution. Let me restate this. Let me rephrase that in a way that's a little more evident. Product opportunity. Okay. Product opportunity. No, I mean, I could sell each one of those. I mean, I'd buy 10 of them for my research boxes alone if they cost under $100. Right. Okay, and so long as they didn't radiate the CPU into uselessness. After other people in the field looked at it and said whether it was good or not, that's called a reputation. this is a theological debate for later. It's a known problem. The randomness that we've got digitally created is not great, but it's getting a little better. And we're beginning to get manufacturers putting this stuff into the chips. Intel's now talking about putting random number generator in every Ether chip. Okay,
all this having been said, remember that even if you run out of randomness, Debian random just starts giving you outputs of SHA, right? So, although it's not
perfectly random, or provably,
right? It's not secure in the information theoretic sense. It is still quite secure in the computational sense, right? Even if you're just pick a random 128-bit value and then just output SHA of that plus 1, SHA of that plus 2, SHA of that plus 3. If anyone could actually get any useful data out of the relationships of there, that would be a very interesting result in itself.
As they say in science, that would be very interesting.
Right, so I'm implying, I mean, we have the same problem with zero knowledge, right? We have freedom servers, they have to
provide randomness without users sitting at the keyboards.
And we're concerned about it. We're adding the timing information of some more interrupts, but there's only so much you can do. And at some point, you come to the conclusion that, look, if someone can break SHA so that they can actually extract information out of this, I'd just like to know that.
If they can break SHA, they've got bigger fish to fry also, most likely. Let's push forward on this because I got a date in a few minutes.
You could hash it.
May I repeat something that we're all going to learn about more? Reputation systems. Okay, don't buy Israeli cell phones. They tend to blow up. Okay, that's a reputation. But it's a very famous example. I want to ask, because I know there's at least two, what are they called? Linux distribution groups in here. What do we as software developers need to do to get this stuff in the goddamn distributions from free countries? Send it.
That was the easiest answer.
Are you? Do you know if you'll be including GPG in the next rev? LSH. All the 50 things.
A working implementation.
Working. Okay. Well, unfortunately, I've got a great working implementation for 2.0 kernels. Yeah, the bug unfortunately seems to be 2.2. That's called 2.5 or 6.
Well, our company is covered. We are responsible for security and all. We've got a big wish list of packages we want to see in the next distribution. Well, and it's very big.
Right.
So it hasn't got millions of maintainers, so there can also always be some packages get into the next version. So, for example, Sweet one would be right on top, where others would be lower priority.
Okay.
But just send what you got and let's see. Somebody needs to put it together that this was specific, so that it really works with.
Well, that's what we pay them for.
They can't do it in time for what we want. I mean, they will do it eventually.
They might not do it in time for what you want or what I want, but yeah, I understand what you're saying. Okay. So let me ask the chaos people. Do I need to send you a copy of the source code also? I can't because I'm an American, but I can, someone here could. You're going to get a lot of copies of the source code, I'm afraid now. No. No. No.
Could you bring crypto in your laptop out of the country here?
I take the, oops, there's no longer any amendments left.
Well, basically, we get the source code. It compiles on the kernel that we're using, which is not currently 100% decided upon. So we might use an older kernel still, at least for the next few.
Yeah, let me ask this, folks.
Pretty much it.
Okay, let me ask, this is really serious. I don't know about you folks. I've been doing this a long time. I stated publicly, not that many people listened, that 2.2 would probably be useless until 2.2.10. I think I hit that pretty much on the mark. Unfortunately, it looks like the networking might be useless a little longer. How many people here in serious fielded applications, like customer sites where the customer is actually making money, you know, real business solutions, are using 2.2.10 rather than 2.0.37? 2, 3, 4, 5. Put your hands down. How many people are using 2.0.36? 3 times as many.
Of those 2.2 people, how many of you are using the SMP support in that? Okay.
Okay, so SMP, oh, 1. Your board just fried. Oh, goody. Did some water get in the mineral oil in the cooler? Mm. Yeah, okay, yeah, that happens all the time. You know, all of my systems that matter are 2.0.36 at this point, not even 2.0.37. There's just no need to upgrade at this point. I mean, yeah, it would be nice, but there's so little that they actually talk on the net besides Pluto and DNS.
The 2.2 kernels contain some very interesting features and pretty wide, like capability support. That's why
Come to me. No, I can't tell you how capabilities work. Never mind. Go to somebody who knows something about Eros or key costs, and then you can find out how capabilities work. It's not the way Linux has implemented them so far.
Well, I think one of the main developments of this stuff is something chaos as well.
Okay.
I think he knows what it's doing.
Yeah, we're using two. We're gonna have to change the name of what we've called capabilities for 20 years because the Linux capabilities just aren't the same. They're not solving the same set of problems. That's all there is to it. What flags? File flags. Oh, the immutables bullshit. Oh, come on, folks. Don't put up with things that stupid. That is the most useless bit I've ever seen on a machine with access to the raw drive in any way, shape, or form. I'm serious. That's embarrassing. What? Great, so now you've got to bring in 3 new systems online to get 1 bit that I still am pretty certain I can get around in my sleep. You know, not that I've tried. I mean, the immutable bit looks nice until you look at how the file system works and, you know, how the disk access works and stuff like that. You know, it's another domino. Yeah, it's one more domino, but it falls with all the others. Yeah, exactly. And you better put them on CD-ROM in such a way that someone can't wipe them out. Whiting them out is, yes.
Don't put the CD in the writer.
Yes, exactly. Don't leave it in the writer. I've been doing something called secure stiff Linux or stiff Unix for years. I've done write-only systems for over a decade now, and it works really well, but only on SCSI disks where there actually is a write protect. Yeah. Actually, to tell you the truth, systems that I consider to be secure don't have users. That's the first step. Okay, this could go on forever. We've been at this for nearly 2 hours.
Music's gonna get really loud in like 2 minutes.
Yeah, the cypherpunks are about to attack your ears with techno gunk, which we have no idea. What I'd like to do is I'd like to invite. Let's not create a new list because we've already got listitis up the ass or something here. I'm going to invite everyone who's interested to come to the Linux IPsec list. It's Linux-IPsec at Clinet, CLINET.fi. It's a major domo run off of Clinet. We have to move our list homing sometime soon because Clinet's falling apart on us, but that's a separate story. In any case, what I think we need to do, or you need to do, because I can't do any of this shit, is we need a low level and a medium level, I think I'll call it, crypto library with all the tools in it. I think from what I heard, you've got a few pieces, Koch has a few pieces, you've got a few pieces. We need to pour all these pieces into one place, make certain we've got the GPL stamp on them. I'd be happy with the Berkeley stamp, but the GPL stamp will do. And somebody who thinks they're skilled at APIs needs to do some work with these to kind of unify them. Is there any sucker who thinks that they've got that sort of time? I know it's fleeting, a subtle illusion, but we're about to do the music warp again. We have a sucker, yay, everyone. Okay, I'll corner you since I know where you're sleeping. Gillnets or dragnets, which do you prefer? Gillnets or dragnets, it's fishing terms, never mind. All right, so that problem is put asleep. Oh. Okay, I want everyone to help me on something, okay? Linus Torvalds is a great guy, but he doesn't know what he's talking about. Something we critically need in Linux is core dumps, okay? Or more specifically, crash dumps, okay? Because right now, my guys are getting systems which are turning belly up, and his little childish quote of, well, anyone who can't figure out what's wrong from just looking at it crash isn't good enough to program Linux, doesn't cut it when you're doing forensic science on something that's dead and gone. Okay, so you know what I'd like everyone to do? I'd like everyone to bug Dave Miller for this because he knows how to do it and it has to be done. Because if we don't get something like that, we won't know what's gone wrong. And this is a classic thing from computer science that was in every Unix up to Linux, and Linux is suffering for it now. Oh, what's his other argument?
His other arguments are that if your kernel has just like put bad values on its stack and jumped into the middle of random process space, do you really want it writing to your hard drive?
It doesn't. You collect it on the reboot.
What? Oh.
It's sitting there in fucking memory when you reboot. The reason Suns are so abysmally slow when they come up in the goddamn prom monitor is the prom monitor is running out literally of ROM because it's desperately trying not to twiddle any of the bits in RAM. Right? Those bits are the last image, right? And if it looks like it's a crash, you write it out to memory and then you blow the memory away. You might have to accept the fact that the PC BIOS during boot has pissed over various parts of the system. But, you know, if you've got a PC BIOS, you're fucked anyway. Go get an open BIOS-based machine. But the tools need to be there because even if you were to write it out as the kernel's dying, okay, you would have more data than you've got now. What you've got now is the ghost of a corpse, and it's really hard to apply a knife to look into the ghost of a corpse. 1, 2, go. Yes, and it usually writes it to the back of the swap for a reason. Yes, yes. It gets stored to the swap when the next kernel boots and notices a mess left. No.
What operating system I know does this? What the operating system? What operating system do not store itself as well when it crashes?
Okay, hold it, folks. Let's try something out. When it crashes, it ain't doing anything useful. It ain't storing itself nowhere because it's crashed. Okay, on all my SunOS boxes, because I was a bigot and I only used computers until 3 years ago when I got shoved into doing Linux on PCs. On my SunOS boxes, there's a phase during boot where yes, there's some point during the reboot when you've got a valid kernel, when you save away the swap garbage and put it in a file and go, this might be a useful forensic tool, maybe.
Yes, and the panic function in the kernel stores that in systems that have format. The panic function stores the memory image down to the swap.
If you're lucky.
That's the point if you're lucky.
If you're lucky. Okay, all I want is everything I've ever had before.
What is that being happy with?
You want Cortex too, and I want to run GDBs on live kernels too, so I can get tracebacks from the process of hanging the kernel, so I can find deadlocks.
Yeah.
When is the deadlock? Why?
Yeah. So what are we arguing about here? I'm lost. Okay, are we arguing about?
The argument was that if your kernel is screwed up, you cannot reliably.
I'm not buying this.
Linus's the statement was Linus's only argument is not you're too stupid to debug a kernel if you can't tell from the oops trace, right? There are valid reasons why you might not want.
And I'm going to disagree with the valid reasons because I've been doing Unix since 1981. And to my knowledge, believe me, I've had plenty of piles of garbage left over from power hits and stuff like this. I have never seen a system that any panic writing kernel images out to memory, stuff, etc., has trashed the disk. I've never seen it.
I was validating your statement that it stores memory. That was
Okay.
You were not perfectly accurate.
I was not perfectly accurate, and I believe I can go show you machines doing this. Let's not worry about it. We all want crash dumps. I don't know. I've never met the man. I've been doing this for years, and I've still never met him. And he supposedly lives down the hill from me. It's just never happened. Okay, so I've never actually heard his arguments other than I was told that it's the broken problem. The problem I quoted you. Whatever.
You can store the crash dumps to a special device like an extra hard drive. I mean, if you're doing development, you can just put in an extra hard drive and okay, trash it completely.
Yeah, I've got plenty of 300 meg drives, which will barely hold my memory images these days. Okay, what? Yeah, crash dumps. I don't care. But crash dumps are important, in my opinion. And I'd like people to make us think about this, especially if, obviously we agree that somehow they need to happen. Is there anything else that people see needs to be done? It is 1700. They're going to turn up the music. It's late at night. We have one more guy, yeah? AFS, something from AFS. A what?
Spell it.
Something different than like process accounting groups.
PAGS.
Yeah, you can store your keys separate from your UI, and like they are owned or from the beginning. You know what I'm talking about?
No, we're clueless.
You want to store your keys, but you don't. You're like running the process here from to like one address to realm, and you are using another external to another realm, and you don't want to mix keys between them. Okay, how do you do that when you're running?
So that's a
What is in the
fundamental hard problem. So here, the distinction is that under Unix normally you have a number of different compartments for security. You have UID 1, UID 2, UID 3, so on up to UID 65534, and then UID 0 is the union of all those and a little more. What would be nice is if me, as UID 2593, I could start sub-processes which have fewer permissions than I do, right? And more to the point, different sub-processes that have almost mutually exclusive permissions so that they can't talk to each other.
Well, not monopoly section, but yes, it's just to store your keys, but it's kind of the same.
Right. So that's hard. It means, yeah.
Yeah, at this late date in our time frame, since we're now outside of our time frame, I'm going to declare this not a crypto problem, but a security problem. Because I got the bigger mic. I think there's a bunch of issues here that we didn't cover. Things like we probably need some sort of insane mechanism for asking the system for some non-pageable memory that also, doesn't go out to, for putting keys in and other stuff like that. There's other work to do here. I'm hoping that this is a conversation that gets started here. And as far as I'm concerned, there ought to be a Linux crypto summit at every Linux meeting in the free world outside of the USS of A from here on out, so that people can discuss these matters and figure out what needs to be done, build tools, and we'll see which ones survive the weird winnowing process of the Linux community. I'm going to thank people for coming and declare this over. So before the music attacks us from that side.